Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. I know that this presentation is going to be controversial because it asks a very basic question. Is the eolian-lacustrine hypothesis of the formation of the Carolina Bays a scientific hypothesis? Soon after the Carolina Bays came to the attention of the scientific community, some scientists proposed that the bays had formed by impacts, but other scientists countered that the Carolina Bays had formed by wind and water mechanisms because there were no traces of meteorite fragments or shocked materials in the bays. The idea that ordinary terrestrial mechanisms had formed the bays became popular, and these terrestrial formation processes remain the mainstream idea today. The emergence of LIDAR has improved the visualization of the Carolina Bays, and some observations have made it necessary to question whether the eolian-lacustrine hypothesis is really a scientific hypothesis. The scientific method is a procedure consisting of systematic observation and characterization of physical phenomena. The formulation of a hypothesis attempts to explain the observations, and testing the hypothesis by experiments can confirm or reject the hypothesis. A rejected hypothesis may be modified and tested again. The most important part of the scientific method is that a scientific hypothesis should be testable. If a hypothesis cannot be tested, then it is not considered a scientific hypothesis. This example has two hypotheses. Hypothesis number 1. The moon is made of cheese because it looks like a ball of mozzarella in the night sky. Hypothesis number 2. The moon is a planet like the Earth because it has many seas, like the Sea of Tranquility. The premises for this hypothesis may seem absurd from our current perspective, but they are both scientific hypotheses because they describe an observable phenomenon and they can be tested by experiments. Samples from the moon taken in 1969 by astronauts disproved hypothesis number 1 and verified that hypothesis number 2 was closer to the truth, although no seas were found. The goal of our scientific inquiry is to determine the mechanism of formation of the Carolina Bays and the Nebraska rainwater basins. We start from the observation that both of these geological formations are shallow elliptical depressions oriented toward the Great Lakes. The elliptical depressions sometimes overlap while maintaining their geometry. Analysis of LIDAR images shows that well-preserved Carolina Bays and Nebraska rainwater basins are perfect ellipses with width-to-length ratios of approximately 0.58. This slide summarizes the essence of the terrestrial and celestial hypothesis for the formation of the Carolina Bays. The most important physical observation that needs to be explained is the elliptical geometry of the bays. Hypothesis number 1 proposes that wind and water can modify the terrain to form elliptical structures. Hypothesis number 2 indicates that oblique impacts can create inclined conical cavities that produce ellipses. Notice that details about the dates of bay creation and the type of projectiles that made the impacts are not included here because they are irrelevant to the geometry. These hypotheses address only the geomorphology and the mechanism of formation of the Carolina Bays and Nebraska rainwater basins. In 1942, Douglas Johnson proposed a hypothesis of complex origin where artesian springs, rising through moving groundwater and operating in part by solution, produced broad shallow basins occupied by lakes. Wave action formed beach ridges at the margins of the basins, and wind action formed dune ridges. Johnson reported that the prevailing wind direction, based on records covering periods up to 60 years or more, may or may not include a significant proportion of winds strong enough to move sand. In addition, at Florence, in the Bay Country of South Carolina, 2 weather stations separated by only 1 mile gave the annual prevailing wind direction as southwest at one station and northeast at the other. Johnson dismissed the elliptical geometry of the bays, saying that the photographs of the bays selected for publication have a perfection of outline that is not typical of the thousands of photographs on file at the various survey offices. In 1954, C. Wythe Cook proposed that the elliptical Carolina Bays were shaped by tidal eddies and that the shape of the ideal eddy is elliptical. Cook further claimed that the long axis of the ellipse is aligned in the direction that varies by latitude. 2 years later, Frank A. Melton wrote a review demonstrating that Cook's formula for the orientation of the bays did not give the proper alignments for bays in the East Coast. When applied to the Nebraska rainwater basins, Cook's proposal does not work at all because although the Nebraska rainwater basins are about the same latitude as the Carolina Bays, they are aligned almost perpendicular to the Carolina Bays, and they occur on terrain that has not been close to any sea for more than 60 million years. In 1977, Raymond Kaczorowski wrote a thesis about the Carolina Bays, which he compared with the oriented lakes in Alaska, Chile, and Texas. He stated that oriented lakes developed in topographic depressions created by various terrestrial processes, and that in all cases, oriented lake development has occurred in unconsolidated sediments easily transported by wave action. Kaczorowski ignored the elliptical geometry of the Carolina Bays by arguing that meteorites generally explode on impact and produce circular rather than elliptical craters. But he used the word spherical rather than circular to characterize meteorite craters. He went on to say that since the bays are not circular, any meteorite that made them did not explode, and that at least some meteorites should remain, but no meteorite material has ever been discovered in association with any bays. Kaczorowski set up a wind experiment to simulate the formation of the Carolina Bays. He carved a round pool on a sand tray and then used a fan to blow over the surface of the water. He altered the direction of the wind by 180 degrees every 15 minutes for 4 hours. At the end of the experiment, the shape of the initial pool was modified by the wind, but it did not have the elliptical geometry characteristic of the bays. In the caption of this image, Kaczorowski wrote that, quote, "The model lake changes from circular to elliptical," end quote. Although he claimed in his thesis that he had produced an elliptical structure, it is clear from the image that the resulting shape is not elliptical. In 2016, Moore and 5 co-authors wrote a paper about the evolution of Herndon Bay. The paper proposes that Herndon Bay, illustrated here, migrated more than 600 meters, leaving a trail of multiple sand rims. The paper relies heavily on the work by Kaczorowski. The authors write, quote, "Seminal work by Kaczorowski, 1977, on bay formation and evolution demonstrated that Carolina Bays evolved through the interaction of strong late Pleistocene directional winds on shallow ponded water, producing oriented lakes. Similar oriented lakes are a relatively common phenomenon globally. Through the use of wind table modeling, Kaczorowski demonstrated that strong prevailing winds from the southwest in the Carolinas were responsible for creating circulation cells that shaped natural depressions into ellipses and oriented bays perpendicular to prevailing wind." End quote. We can recall that Douglas Johnson reported that 2 weather stations separated by only 1 mile in South Carolina gave the annual prevailing wind direction as southwest at one station and northeast at another one, using records covering periods of up to 60 years. We also saw that Kaczorowski's experiment did not produce an elliptical structure. Kaczorowski's experimental pool resembled a football more than an ellipse. However, notice that Herndon Bay has a perfect elliptical shape. By what mechanism was the elliptical shape of Herndon Bay conserved through many millennia of evolution and a migration of more than 600 meters? What are the physical forces that direct the sandy soil to achieve such mathematical precision? The eolian-lacustrine hypotheses have no answers. The creation of elliptical structures has a foundation in geometry and in the laws of physics. From the ancient Greeks, we know that ellipses are conic sections. A cone cut at an angle inclined to its central axis produces an elliptical surface. From physics, we know that a projectile traveling in a viscous medium produces a conical shock wave. Thus, an oblique impact on a viscous surface will produce an inclined conical cavity, which viewed from above will have an elliptical shape. It is pure and simple. There is no need to invoke artesian springs, marine stages, or prevailing winds. This mechanism will work in Nebraska as well as in the East Coast. It is just geometry and physics. The lower image of this slide shows oblique impacts on a mixture of pottery clay and sand. This is a physical model that supports the glacier ice impact hypothesis published in 2017, which proposes that an extraterrestrial impact on the Laurentide ice sheet ejected pieces of glacier ice in ballistic trajectories, and the secondary impacts of glacier ice produced inclined conical cavities that transformed into Carolina Bays by viscous relaxation. We now come back to our initial dilemma. If the eolian-lacustrine hypothesis does not have the means of proving which way the wind was blowing during the formation of the Carolina Bays, then the hypothesis cannot be tested and it cannot be a scientific hypothesis. If a numerical model or a physical model cannot be constructed to produce geometrically elliptical features by wind and water, then there is not even theoretical or experimental support for the eolian-lacustrine hypothesis for the creation of the Carolina Bays. As mentioned before, the scientific method requires that a hypothesis should be testable. At the current time, the eolian-lacustrine hypothesis of the formation of the Carolina Bays does not seem to meet the requirements of a scientific hypothesis. What do you think? Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.